Welcome back to the ChemDoctor, and in this video what we're going to do is use the concept of molar volume, and molar volume of a gas is the volume of 1 mole of gas at a stipulated temperature and pressure, and the conditions that we're going to stipulate here are conditions of STP, which is standard temperature and pressure for a gas, and those conditions are 273 Kelvin and 1 atm of pressure. All right, so this is the 6th video in the series on gases, and the previous video described what molar volume of a gas is at STP and how it's calculated. All right, so let's now take that concept and apply it to solving a problem. All right. So the issue at hand is to calculate the volume of 40 grams of carbon dioxide gas at STP. Now, what we learned in the previous video is that literally at STP, 1 mole of a gas, and this is a unit conversion factor or unit multiplier factor, that 1 mole of a gas is equal to 22.41 liters specifically at STP. So how are we going to solve this problem? All right, the easiest way to do it is to utilize this unit conversion factor. So this problem is going to require 2 steps. In the first step, which hopefully the viewer is familiar with by this stage in your course, either a college course or an advanced placement course or a high school chemistry course, is that we need to get the quantity of CO2 we've been given here from mass to moles. So we're going to utilize the molar mass of carbon dioxide, and in a unit multiplier type of problem. So we want to use the molar mass to multiply times the 40 grams of CO2 in order for the mass of CO2 to cancel out. So we're going to have 1 mole of CO2 over 44.01 grams. All right, and where that came from, right, this should be 12.01 grams per mole for the carbon, and then oxygen is worth 16 grams per mole, but there are 2 of them, so that's a total of 32, and the sum of this gives us the 44.01 grams. Now, some periodic tables are going to have the oxygen in here at 15.99, something like that, so this number might be a little bit different than the way your professor is calculating it, so just pay attention to the fact that we might be utilizing different periodic tables. All right, so this is going to give us 0.9089 moles of CO2. Now, utilizing this unit conversion factor, because pay attention to the fact that we are at conditions of STP. So in this problem, we can utilize this unit conversion factor to do a very simple calculation to find our way to the volume of this gas. So what I'm going to do is rewrite the moles of the CO2 here. And then we're utilizing, again, unit conversion or unit multiplier method. And what we're going to put in the numerator is, we recognize that we're solving for the volume. So I'm going to put 22.41 liters in the top, and in the bottom I put 1 mole, because this is the relationship. 1 mole of a gas is exactly equal to 22.41 liters at STP, and this is going to be 1 mole of any gas. It doesn't matter whether it's CO2 or N2 or oxygen, methane, any gas that is at STP will have this relationship. All right, now you can see clearly that the moles are going to cancel out, and we've solved for liters. So I'm going to put my liter over here, and I look at my units before I crunch any numbers, because I want to see that I set up my unit multiplier method correctly. And running the numbers now, what we get is 20.4 liters for the answer. Now let's say that you're just not able to see this connection, and the only thing that you're capable of doing is utilizing the ideal gas law, where PV is equal to nRT. So the main point here is I just want to prove to you that using either method works. This one up here is quite a bit easier because it's cleaner and elegant and it's much faster. But let's go ahead and use the ideal gas law just to prove that the whole system works. So we're going to solve for the volume, which means I'm going to divide both sides of my equation by the pressure. So this is going to be nRT over P. And now we can go ahead and plug in the values that we previously solved for. So we're going to have 0.9089 moles of the CO2. All right, and that will be times R, which is 0.0821 liter atmosphere, divided by mole times Kelvin. The temperature is 273 K, and the whole rigmarole is going to be divided by 1 ATM. Now, you can see using this method that, again, looking at the units before we crunch the numbers, the moles cancels out, the ATMs cancel out, the temperature, K value here, cancels out, and we have successfully solved for liters. And when you run the numbers in your calculator, you find that you're going to get exactly the same volume that we calculated above. But you can see in the lower calculation here that it required quite a bit more work. So your recognition when you're reading these problems that your professor or your teacher are going to ask you to do, either in homework or in test questions, is you need to read the question carefully and pay attention to the conditions that they're stipulating for the problem. Because if the problem is at STP, then you can utilize this unit conversion or this unit multiplier relationship very easily to do a very clean and quick calculation to find the volume. Or even for that matter, you could flip this around and solve for the moles of an unknown, for example. And also, as I finish, just before I finish the video, I want to point out that if you are at conditions where in the problem they have stipulated fixed temperature and pressure, you can also find this relationship for a different set of conditions, and then you can use it in the same kind of way as long as you're utilizing it under those new specified conditions. All right, and with that, I'm going to go ahead and close the video.